Okay, so what I'm going to do is walk through an error example, and actually I'm going to start all the way and do linear best fit. I'm going to talk about sensitivity. I'm going to go into some of the noise that's like in the example that you have for your homework, and then we'll do kind of the error. So I've prepped a few things here, but I'm going to walk through it. So my data is just S and E, right? I'm keeping this pretty generic. So S is the stimulus and E is going to be its output. You can pretend it's in volts, whatever you want. You can see that S is just going from 1 to 7. E has this range of values. You'll notice 1, 2, 3, 4, 5, 6, 7 different values. K, which I need from those equations that are going to be used to estimate the linear best fit. That's it. Just K needs to be used in those equations, right? And so what I'm going to go ahead and do is kind of walk through how I would set this up. And here I'm using Octave. You can use MATLAB, Python, Fortran if you really feel like it, although I imagine that's pretty hard. So let's go ahead and do it. So B is our slope, right? And we're going to write this nice fancy equation to do it, but we're prone to errors if we just write it as is. So what I want to do is start off by defining a variable SE, which is just the multiplication of S and E, right? So SE. In MATLAB, that dot times means it's going to do it element by element rather than doing like matrix multiplication. Okay, so I've created this vector SE. The semicolon means I've suppressed the output, if you're not familiar with the MATLAB. So I know that it's stored in that variable. And then I can go ahead and I can create the S squared variable, which I'm just going to go ahead and say is S2, which is just S dot squared. Same reason. I don't want to use the the matrix multiplication of that. I just want to do element by element squaring. So now I've created that. And now the only thing that I have left to create is the sum variables. I'm going to differentiate these. Normally, I'd probably put an S in front of them, but because I'm already using S, I'm going to use X. So I'm going to say XS, which is going to be the sum of S, is going to be equal to sum of S, right? Makes sense. So S is stored. I can do the same thing throughout, and I'm going to stop talking for a bit so I can do this without messing up. Oops. That was a mistake. I just overwrote my SE because I forgot to write the X. So XSE is equal to the sum of SE, right? Because these are the variables that we need for that equation. I have XE, XSE, XS, and I guess I need a sum of S squared. Okay, now I can start setting up for the slope, which is going to be K times the sum of SE, so X, move my mouse there. I'm just pulling this straight from the notes. You can find it in the book or the appendix or wherever else you needed to. Oh yeah, and K, I just took the length of S, right? You can manually just say it is however many variable. I use length of S. Okay. XS2. Sorry, I always mess that one up. The difference between the sum of S squared, which is S2, and minus the XS, which is the sum of S, and that whole thing is squared, right? So another way of clarifying that, it would be parentheses around here, right? It's the sum of S squared. Okay. Oops. What did I do? XE is undefined. Did I not define XE? I didn't. So let's go ahead and define XE is equal to the sum of E. Okay, so B is now equal to 2.829. That should be our slope. Hopefully we're correct. And then I'm going to go ahead on and we can start writing the equation for A, which is our intercept, right? It's going to be that same kind of roughly the same form where we're going to have XE times by XS2 being careful to make sure that we keep those variables correct. And I typoed, so I'm not the world's greatest typer. Apparently, I'm worse than usual. Negative 0.9857. That feels wrong to me, and I'm trying to make sure that I didn't do anything obvious. Okay, let's go ahead and find out if I messed this up somehow, because we can kind of figure this out pretty easily. There's a couple different ways that we can do this plot. It can kind of be helpful if we define the plot in terms of like individual points for the measured data and a continuous line for sorry, my brain just scattered. So a continuous line for the estimated line and then points for the measured. And we can do that if I just scroll up through some of these to make sure I remember how to do that right. Okay, so I'm going to go ahead and use scatter of the X and Y. So S is our X and our Y is E. I don't actually know if you guys can see that because of the way the screen share works. So I'm going to pause the recording for a minute and bring up a different recording mode.